Hi everybody. In this video, we're going to talk about some problems encountered in DP exams for the topic sequences and series, mathematical analysis and approaches for both SL and HL students. So first of all, I'd like to start with the formula that you already know. So we have here some formula. You know, you are going to have a formula booklet. There is a certain format for that, and you're going to use more or less this formula there. These are that we already have studied. So you should be familiar in any way, even if you are not given, even if you don't have the formula, you are familiar already with that, and I'm sure that you can make a good use of it. So first of all, let's start to count some problems which students encounter, or some exam style questions. So first of all, that they face in regards of the topic sequences and series, students usually are asked to find the common ratio with a given data. For example, let's consider this problem. A geometric sequence with a first term of 2 and a sixth term of 64. So we have a geometric sequence which has got U1. It's better to write all the time the data here. U1 is 2, and the sixth term is 64. We need to find the common ratio. This is a typical exam type question which you can encounter in exam. How to solve such questions? Well, you know, if we are giving you one, and actually we know the formula for U6, we know that UN for any term n, if we are talking about the geometric sequence, UN is equal to U1 times ratio to power n minus 1. So actually we have U6 here. Then in this case, U6 will be equal U1 times ratio to power 5. If we place everything in its place, we are going to get, so 6 equal, U6 is equal 6, U1, which is 2 times our ratio. We don't know the ratio. We are going to find it, ratio to power 5. So actually, our ratio is equal to power 5 is equal to 3. And from here, we can get the ratio is equal fifth root 3. So this is for geometric sequence. In arithmetic sequence, you can face up with the same problem, but then you're supposed to use UN equals to U1 plus n minus 1 D formula. Now let's go to the next one. The next one is about a geometric sequence with a second term of 10 and the fourth term of 250. What's different here? In the first one, it was easier because we were given a first term, but here we have a second term. So anyway, we have to be ready to solve such questions. So if we have a second term of 10, so U2 is 10, again, it's better to write all the data, and U4 is 250. Again, it is geometric sequence. So U2, we can write instead of U2, U1 times ratio. It's 10. For U4, we can write U1 times ratio to power 3 is equal to 250. So how we can deal with that? Usually in these cases, it's better to divide the terms. So if you can see, if we divide the second equation by the first equation side by side, then look what we are going to have. U1 to R cubed, the U1 times R cubed divided by U1 times R is equal to 250 divided by 10, which is 25. So U1's cancelled. We get R squared equals to 25, where R is obviously 5. So actually what we have here, when we divide two equalities, usually in geometric sequence, there is a good way to cancel U1 in such type question. So do not forget this. Because if you forget it, we can face up with a more complicated question, equation with a higher degree, so or maybe with fractions and so on. So it's better to know how to approach it. For the if we have the arithmetic sequence, in this case, the same type of question you can see in arithmetic sequence, then it's better to subtract to get U1 cancelled. So let's pass to the second question. The second type of question is that we are given some term, and the term is a number. We need to find n. So we need to find the number of the term that we are given. So for example, look here. The nth term of an arithmetic sequence is given by un equals to 15 plus 5n. Find the number of the term which is equal to 150. Actually, if we are given un, then then we can find all components here. So we can find the first term, the second term, the difference. We can use the sum formula here. Then consequently, here we can do some one or two steps to find. So which is our term is equal to 115. So actually, we don't know which term. 15 plus 5n is equal 115. So obviously 5n is equal 115 minus 15. 5n is equal to 100. So n is equal to 20. So if we are given this arithmetic sequence, n is equal to 20, the 20th term will be equal to 115. The next type of the questions are we are given the sum. Usually in arithmetic sequence, we need to find some term. For example, we request to find the 10th term, 15th term, and so on. So to solve this type of questions, it's important to realize that if you are given a sen here, so obviously we can find the terms also U1, U2, U3, and so on. How we can find? For this purpose, do not forget that S1 is always U1. So the first term is in our series, in our sums, is usually U1. So this is the important part of this story. So S1, if you calculate S1, it is 3 times 1 squared. Instead of n, we place 1 plus 5 times 1. It is 8. So S1 is 8. Okay, but is this data enough to find U10? Not yet. What we can do, we can find S2. Let's see what is S2. S2 is 3 times 2 squared plus 5 times 2, which is 12 plus 10, which is 22. S2, on the other side, S2, we know that it is U1 plus U2. So it is the sum of first two terms. So U1 plus U2. So actually, U1 is 8. We already know U1, it's 8. And U2 is, we don't know. We are going to find U2 because of the difference. So S2 is 22. We already know this. So 22 equals 8 plus U2. So U2 is equal to 22 minus 8, which is 14. So our second term is 14. So obviously our arithmetic sequence is in the form 8, 14, and so on. We can see the difference here. The difference is obvious. It is 6. 14 minus 8 is 6. So actually U10 is equal, then we know the formula, U1, which is 8 plus 9 times, because we are looking for 10, 10 minus 1, 9 times D is 6. So you can calculate it. and you can get the answer. So another type of the question that we encounter in usually in paper one algebra topic is that finding the unknown using some property. So we are looking for some unknown term, unknown variable, but we are requested to find to use some property. Uh, I recommend, if you talk about arithmetic sequence, I recommend to not to forget that we know if we have U1, U2, or U3, and so on. If it is an arithmetic segment, we know the property which makes this sequence arithmetic. That is U2, the middle one is equal to U1 plus U3 divided by 2. It's an average of uh, two neighboring terms. So U2 is equal U1 plus U3, 2, average of two adjacent terms. So we can apply this property for solution of such questions. So in this case, 3x plus 2 should be equal 12 plus 22 divided by 2 because we are given here the first three terms. So this is U1, this is U2, this is U3. So obviously 3x plus 2 equals to 34 divided by 2, which is 17. 3x equals to 15 and x equals to 5. So actually we are requested to find x, it's 5. Sometimes we are requested to find the term. If we are told to find u2, the second term would be 3 times 5 plus 2. Because instead of x, we place 5, so it's going to be 15 plus 2, which is 17. So our arithmetic sequence is 12, 17, and 22. So this is also the type that usually encounters. So what we have done, we use the property. How else we can do it? We know the differences. If it is arithmetic sequence, the differences between them is always constant. We can use this property also. For example, 3x plus 2 minus 12 should be equal 22 minus 3x plus 2. So this is another way of solution. If you write like this, you will come to the same result. So this is our difference. This is also our difference. So we know differences do not change; they are constant. So we can use this property also. And the same way we can approach the geometrical series. The another topic here is infinite series. We studied this topic, infinite series, the sum of infinite series when ratio is between -1 and 1. We know that the sum formula is U1 divided by 1 minus R. So this is a typical question which requires knowledge of this formula. The first term of an infinite geometric sequence is 5. The sum of the infinite series is 100. Find the ratio. So let's write what we have, which data is given. The first term, so it is U1 equals to 5. The sum of the infinite series is 100, so S is 100. So we need to find the ratio. Obviously, it's obvious to put all the numbers here. So it's going to be 100 is equal 5 out of 1 minus R, where it makes 1 minus R is equal 5 out of 100. So R is equal 1 minus 5 out of 100, which is 95 out of 100. That this is our ratio, which makes the sum 100. So that in this case we had the ratio. We can do the same thing even if it is not infinite geometric series. I suppose we are going to have some similar question now. So suppose now we have the first term of a geometric sequence is 5. The ratio is 2. So let's write U1 is 5 and ratio is 2. We are requested to find the least value of m for which Sn is greater than 315. We are not taught that this is an infinite sequence, infinite series, because it can't be. We said that for our infinite series, to be able to find the sum, this R should be between -1 and 1. In our case, it is usual geometric sequence. So we have this theta, and Sn should be greater than 315. So let's first remember what is the sum for Sn. So the sum of first n terms in geometric sequence, it's u1 times r to power n minus 1 divided by r minus 1. So if we place everything, u1 is 5, r to power n, r is 2, so it's 2 to power n minus 1 divided by 2 minus 1. So it is going to be 5 to power n minus 1. So we can write it like this: 5, 2 to power n minus 1. You see, this is our Sn, and it should be greater than 315. We are looking for n, 315. Actually, we are supposed to use this in equation to find n. 2 to power n minus 1 is greater than 63. So 2 to power n is greater than 64. We know that in this case, n should be greater than logarithm 64 base 2, which is 6. So n should be 6. Obviously, the least value should be here, n is equal to 7, because n is a natural number. It shows the place, the place of the term. So that's why it should be natural number. So n is 7. In our case, this is the least value when our Sn is greater than 315, as we cannot take 6 also. That depends on the nature of the inequation. We can have the same thing with Sn is greater equals to 315. Do not forget the least value which satisfies in this case, in this inequation is 6. So here we are going to get 6 as a solution. So that depends on that. So do not forget to look at the inequation itself. That depends on the inequation also. So this is another type of the question which we can encounter. In arithmetic sequences, you can have the same question, same type of question, but anyway, the formula, the general formula is the clue here for the solution. Uh, Usually in exams, we have applications. So if you remember, we have talked about simple interest and compound interest for economical applications of sequences and series. And here I selected 2 of exam type style questions, which you can have in the exam. The first question is, Mary starts a new job with an annual salary of $90,000. At the start of each new year, Mary receives an annual salary increase of $8,000. So here, if you can see, we are given the increasing number. So each time, each year, the number increases by a number, by a certain number. It can increase by a percentage. We are going to look at the case when it increased by the percentage also. Let Mn represent Mary's annual salary at the start of her nth year of employment. Find the formula for Mary's annual salary. It's not difficult to see that it is an arithmetic sequence. If we denote it by Mn, yeah, it should be M1 plus D times n minus 1. So this is the formula that we can use. M1 here is the 90,000 plus difference here is, each year it increased by 8,000 times n minus 1. We keep n because we are requested to find Mn. So it is 90,000 plus 8,000 and minus 8,000. So you can see it is 72,000 plus 8,000 n. So this is a general formula for Mary's annual salary. It's not difficult to see that it is an arithmetic sequence. Now consider the same problem with geometric way. So look, Mary starts a new job with an annual salary of $90,000. At the start of each new year, she receives an annual salary increasing of 2% of her previous year's annual salary. From here, we understand that Mary's salary increase compoundly. So we call it in economic science compound interest. But the solution to such problems come to a usual mathematics that we know, basic mathematics that we know. So if we do not, in this case, we are also request for the formula for Mary's annual salary. If you know, if you can see it is 2% increase. So we know that if number A increases by 2%, it means that we multiply this number by 1.2. So actually, this is a factor, increase factor here, 1.02. We are going to use this idea here. So Mn here is equal 90,000 times M 1.02 because it is the percentage. It is 90,000, so it is 100% plus 2% also each time. But as it compounds yearly, it means that we get the previous year's increase here. So 1.02 to power n minus 1. This is the formula for Mn. Here you can use also, you can see it's the general formula for also our geometric sequence. Un equals to u1 times r to power n minus 1. Our r is 1.002. So do not hesitate to use this formula for such applications. Well, it's the end of this video. In the next video, I'm going to talk about the problems which you can encounter in combinations, and also you can encounter in solution of the problems with proofs. I wish you good luck, success. See you in our next video.